Nvidia controls the AI chip market. By some analysts' estimate, it controls 80% of the AI market. Their products went almost unchallenged for a long time, allowing Nvidia to deepen their moat in the field. They offer the best GPUs in the market with proprietary APIs exclusive to them in CUDA, tying it all together perfectly with data center specific hardware enabled by their purchase of Mellanox. For enterprises big enough, messing up with other exotic solutions will end up costing more. For example, they will have to figure out data delivery, mess up with code inconsistencies for using non-CUDA enabled cards, and usually settle for less than optimal hardware. But the tides are changing. Nvidia won't lose the market anytime soon, but their moats are showing cracks. They are being challenged on all fronts. The better hardware for the task, the CUDA API hegemony, and the integration of all parts.
What's up investors, Sneer here. This video is based on research I published in my newsletter. In the written form I have more details and links to references that I mention in the research. So if you're interested in the more details and want to follow links and more references, check out the link in the description below. Speaking of it, while I did this research, a friend of mine asked me why I do all this deep research on this subject. If I believe in AI technology and I believe that the market will take over, then I will just need to invest in the broad market of AI and it won't matter in a few years as I will be profitable anyway, which is a sentiment I very much connect to in regular markets. But in today's market with the exuberant prices and especially with the exuberant price of Nvidia, I think it calls for deeper research because as the price is higher, the margin of error is lower, and I'm afraid that investing in Nvidia right now it might be a foolish movement because if we don't have the margin of error available in the prices of the company, and that's true I think for almost every company that does AI these days, we need to lower the margin of error by doing rigorous research and understanding the market.
Deep learning AI, driven by neural networks as opposed to machine learning that is often also referred as AI, is driven by high volume of high precision, as in floating point precision, calculations done in parallel. By the native architecture, GPUs are better equipped for this task. But to utilize the GPU hardware, you need an API to bridge the gap from the developer to the hardware itself. Multiple APIs exist and have been existed for a long time. But when AI first gathered steam, Nvidia had CUDA ready with APIs specific for neural networks in an API called cuDNN that enabled the neural network workflow perfectly, which other APIs didn't have, for example OpenCL, which was the open source API. With Nvidia having the better API and the better hardware, almost every AI framework like TensorFlow or PyTorch or Caffe or any other like that didn't bother implementing the framework for other APIs. They just implemented it for the proprietary CUDA, which locked in a lot of researchers and enterprises working with AI directly to Nvidia. There is some discussion within those framework projects to implement other APIs. For example, TensorFlow had a discussion since 2015 about implementing OpenCL, which they closed last year because they implemented OpenCL for the mobile version of TensorFlow. But the mobile implementation wasn't the intention of the issue. A mobile implementation was necessary as mobile processors doesn't have Nvidia GPUs, and any API to communicate with the implemented GPUs within mobile chips to have better AI inference is better than none. So the OpenCL implementation for mobile TensorFlow is intended for mobile inference of AI models and not for server-side model training, which was the intention of the original issue. On the other hand, PyTorch issue from 2017 about implementing OpenCL had a direct answer from the maintainers, saying outright that OpenCL is bad in terms of performance, it doesn't worth it, and other vendors like AMD already go forward with things like HEAP, which we will talk about, that doesn't make sense to do all the work for OpenCL when we'll perform worse and AMD will have a better solution soon enough.
By having the better hardware and the proprietary CUDA API at the right time, Nvidia was able to take control of the AI market and build control around it. With almost every neural network model and research paper based on Nvidia's hardware and CUDA API, even if unknowingly just by being tested only on those hardwares and APIs, Nvidia put themselves in a position where it's very hard or even impossible in some cases to replace it. But changes happen slowly, and I think they are happening in this market right now.
Researchers and programmers' time costs a lot more than any hardware, and a lot of the ecosystem of the AI world is already based on CUDA and Nvidia's hardware, so it doesn't make sense to rewrite it as researchers' time costs a lot more. So the only sensible way to break Nvidia's monopoly is by having an abstraction on top of CUDA or on the level of the frameworks that will be able to utilize the prior work of the researchers and programmers. AMD ROCm, Radeon Open Compute, is a project that wants to do just that. They have a part of the project called HIP, which is the equivalent of CUDA in AMD's world. But the difference is that HIP is open source and open standards, so you can implement it for every hardware. But having another open source, open standard is not enough. We already have it in OpenCL. That's why AMD also created a project called Hipify that automatically transforms CUDA code to HIP code, thus automatically allowing every previous code written in CUDA to be supported in AMD cards or any card for that matter, because the standard is open. They even went forward and created ports that they support themselves for TensorFlow and PyTorch on top of a heap with the Hipify project. So you can write right now code in TensorFlow and PyTorch that works on AMD directly. So if you already have a code base on, it will work with AMD cards. Of course, that's not perfect and it might require some changes, but it's already going on and it's already working good enough. If an enterprise is sensitive to budget, they can go with AMD solutions and using this project without transforming all their previous code, which creates a great competition to Nvidia's solution. An example of how production ready the HIP code is by looking at the recent release of Blender 3. Blender is a 3D modeling software that requires a lot of GPU acceleration to perform well, and having HIP in production for Blender 3.0 means that HIP is good enough and ready enough to be in production environment, enabling the utilization of the GPU, the general programming on the GPU. It's not AI specific, but it's another demonstration of the utilization of the hardware with the API of HIP and that it's ready. So with AMD ROCm and the HIP project cutting CUDA on the hardware level on directly the API, there are also competitions operating on the frameworks like TensorFlow and PyTorch. For example, we have specialized hardware, which we will talk about more, like a Google TPU or AWS Trainium cards that implemented SDKs specifically for the frameworks like TensorFlow or PyTorch to enable them to work directly on those cards. So it breaks the CUDA monopoly specifically on the framework. Again, this is not perfect, and for complicated enough project, enterprises won't be enabled to just use it as is. We will need to make some adjustments, but in some projects the adjustments might be minimal enough that given the offerings from Google or AWS and the cost reduction by moving to the cloud instead of maintaining your own servers as you need to do with Nvidia right now, might be worth it. One last thing to mention is that there are a lot of other APIs offering. For example, there is Intel Open API that is an open standard and open source project, and they claim to compete with AMD ROCm, but they are far behind. They only support Intel hardware, which is not even hardware that is in the same levels of Nvidia or some of AMD's offering, so it doesn't really matter when we look at AI competition. So we've talked about the API side, now let's talk about the hardware side. And let me start from the end. Nvidia is so worried about the hardware side that they are willing to give up their monopoly of the API side in terms of CUDA. They allow third parties to implement CUDA in their hardware and use it publicly. This targets mostly companies like Google or Amazon that offer their specialized hardware through the cloud. They want their customers of those cloud services to still rely on CUDA. I go into more details in the written form in the newsletter, but what you need to know is that neural network specifically is optimized for certain types of floating point, which is an epic coincidence that the GPUs had what is called FP32 But FP32 isn't perfect for neural networks. It's good enough, but there are some other floating points configuration, for example bfloat16, that perform much better for neural networks. So Google, for example, created something called TPU that is their specialized hardware for AI, and Amazon does something similar with the program called AWS Trainium. Now, many other companies that care deeply about AI produce their own hardware, companies like Apple and Facebook, but Google and Amazon specifically offer their specialized hardware through the cloud, and that's what matters here for the competition against Nvidia. You can't buy these specialized cards, but you can use them through the cloud, which is a completely different business model. It's not directly competing with Nvidia because some enterprises will need to have the cards and the computational power within their own servers forever, but for most of the enterprise consumers, cloud offering is good enough and even better, as they don't need to manage the servers themselves. One example you can see right now on the screen is the AlphaGo project moving from GPUs to TPUs of Google, and the performance is so much better and so much more effective. But the subtext to this kind of thing is that between versions, they almost completely rewrite the model. That's something that will be required when you move to new hardware. The abilities are not exactly the same as the GPUs, and even though you can write it on TensorFlow and use the same code base, it will require some adjustment. So it's not that easy to move, and it's something to keep in mind when we think about the future. So let's talk about the future. My conclusion from this research is that hardware for training neural networks will be commoditized, prone to pricing war. That's not the case at the moment though, and won't be the case for some time, as moving away from Nvidia's solution and Nvidia's ecosystem is very hard. I only mentioned the benefits of using the hardware or using the APIs, but the entire ecosystem is much broader than that. For example, I mentioned the Nvidia purchase of Mellanox that offered a lot of solutions on the data side. So if an enterprise runs a large data operation that is fed into a model that is retrained continuously, they absolutely need this solution that works best with Nvidia's offering. So moving away from that will be much harder. Everything else I mentioned, all the reliability on CUDA and Nvidia cards, it doesn't worth it to move right now, but the tides are changing slowly. It becomes easier to move to other solutions, either by using AMD ROCm project to utilize AMD's hardware on the server side to train models, or by using the cloud offering from Google in TPUs, or from Amazon in Trainium, or anything like that. If you start now and you depend on higher abstractions that allow you to move from solution to solution more conveniently, it lowers the moat of Nvidia. Nvidia will lose its advantage both in using CUDA to lock in users and in having the better hardware. That's it, guys. I hope this research was informative for you. Check out the newsletter link in the description below, as it has much more details and links to everything that might be interesting here. And I'll see you next time. Bye bye.